Hello everyone and welcome back to another Universe Sandbox 2 video, and today we're doing another idea commented by you guys. So what we're doing today is we're going to be surrounding the largest exoplanet with the brightest stars. We're going to see if the planet completely vaporizes, because if you remember quite a while ago I added the brightest star instead of the sun, and it roasted every single object in the solar system apart from Sedna and Planet 9. I think Sedna even died out. I think it was just Planet 9 that was the only survivor. So even Jupiter, the largest planet in the solar system, was vaporized by the brightest star. So we're going to be surrounding the largest exoplanet with, with the brightest stars, and we're going to see if it survives or not. So we'll try it at different distances, but we'll put it around. So we'll just see where Jupiter is here. So to get a test of to see how powerful they are. So we'll put them, all the stars, 5.2 AU away from the planet, and we'll see what happens. So let's actually go into a whole new simulation here. Actually, no, what I can just do is I can just do this because I want to keep the cool Christmas background on. Oh, and the sun survived apparently. Anyways, guys, well, I'm just quickly setting up. Just a many thanks to everyone who subscribed. We are 2 subscribers away right now from 1,700, so that's just amazing. Just cannot thank you. But let's see if we can still try and get that goal of 2,000 before the 1st of January 2018, because that would be awesome. But yeah, I think that's a nice little goal to set. So anyways, largest planet. Oh, I forgot I still have the galaxy-sized gas giant. Forgot we still had that. Alright, so what we got next? Largest exoplanet, you are... Damn it, where is it? I always lose where this one is. There it is. Okay, it's moved slightly since I last used it. Alright, so we'll put it at a distance of... we'll have to lock the positions of objects here as well. So let's put it at 5.2 AU. So pretty much around this distance here. So yeah, 5.18, that's close enough. So now what I'm going to do is we're going to delete the old sun. So there we go. So let's go back to the planet now, and we're going to surround it with these stars. So first of all, we'll start off with R1, since that's the one we will start off. So wait, R1, where you are. Yeah, R1 36A1. So we're going to put this 5 AU away. So 5.2 pretty much. So 5.2, let's put you... Okay, let's just put it in a still mode as well. So 5.2, got to look very carefully here. Okay, 5.21, that works. So there's one. We'll use A to Carinate A as well, since you're also one of the brightest. So 5.2444. There's a lot of preparation for this one. So yeah, 5.2. Okay, put that there. Oh, this planet is going to get roasted. So then we'll get Melnick 34. So it's also one of them. So 5 AU, please. There we go. 5.2. Okay. So there's that. Then we've got R1 or R136A2 now. So let's get U in. So R136A2. Blah blah blah. Okay, so 5.2. Right, there we are. Then we'll get the next one. I'm not even going to say their names at this point. It's just annoying. I always muck up. So there's that. And then the last one is. Or is that all of them already? And then we'll use the pistol star. Why not? Over here. So 5.2. like so. So let's put you there. So 5.2. There we go. So now what we need to do is we need to position lock all of these, because we don't want them colliding. So position lock the A to Carinate, then we'll do R1, then we'll do the other R1, and then this R1 over here, so number 3, then the pistol star, and then Melnick 34 will lock you as well. So now they're all locked, and then HD in the middle will lock that as well, so it cannot move. And just look at this. No matter where you look, it is daytime. The only dark point is under here, since there's no star above or below it, as you can see. So if we just land right in the north here, wherever we look, there are stars, and it's just going to stay like this. So now we just need to see, will this planet get vaporized or not? So ready for the moment of truth. Let's slow down time, because this thing, either way, this thing is going to heat up in temperature very fast. So let's go down here, hit play. Now, as we can see, it's already, if you look carefully, its clouds are already starting to glow orange. So pretty crazy. We literally just hit play and they appeared. So we're traveling about 20 minutes right now, and it's already heating up in temperature. So this is going to be interesting. Let's just look on materials here. Is it losing any mass yet? Okay, so it's not lost any mass at all if we look in the menu there. So if we start to speed it up now, as you can see, the temperature is going to get hotter and hotter, as we can see on the little picture here on the top right. So let's speed up a little more. Okay, here we go. Now it's heating up. So is it going to get warmed up anymore? So let's see here. Oh, the Planet 9's still over there. Wait, what the heck is going on? Whoa. I think Rouge Limit is sort of I think Rouge Limit is sort of tearing these stars apart. Look, R1, which has the most mass, is sucking the material from Eta Carinae here. And then Planet 9 out here is just chilling at 600 degrees. But is HD in the middle here? Is that actually... Is it... Oh my god, what is going on? I know this isn't intentional, this wasn't meant to happen, but what is going on? Look at this. Well, I wasn't expecting that to happen, but from the way, if we just pause quickly, from the way it looks, it's not losing any mass. So, wow, that is close. Look how close that is together. Oh my, is this just losing all its mass? 666 mass. Oh my god. 400. Wow, this is pretty bonkers. This Pistol Star has completely disappeared because it's obviously had the less amount of mass, and this planet is just doing nothing. Like, what is going on? Look at this. But still, there is no mass being lost here. So we'll try this out. We'll just reset this in a second to just double check it. But oh, Eta Carinae has just been turned into a planet now. Look at this. It's a planet. And these guys are right. Wow, look how much mass this has. Its mass is fluctuating a lot as well. Oh, and now this star's sucking up all the mass. Look at R136A2, 500 mass of sun, and it's still increasing. The R1 is getting smaller in mass. Look, what is going on? But still, at least they haven't collided and no supernovas have been made, so this still isn't losing any mass. So what I want to do is we're going to quickly add a slightly smaller exoplanet in here. So this is what, like, I think this is like in the top, or the second biggest, or one of those, like in the top 5 biggest exoplanets. So we're just going to place it there, and then we'll position lock this. Does this get affected in any way? Oh, this one's losing mass. There we go. Maybe it's just the big one's a little buggy, but yeah, this one is losing mass. And remember, like, if we just compare it to the largest exoplanet, the largest exoplanet is quite a lot bigger, but still, this one is still relatively large. Like, there's the largest exoplanet, and then this one here. So HAT P32b, this is quite a large one as well. So I know it's a lot smaller, but still, this is still a quite close representation. So maybe it's because that one is so big, it's like it's in brown dwarf state, so it doesn't lose mass since it counts as its own star. Maybe I don't even know. But this guy, let's see if it vaporizes. So if we completely speed up time as fast as we can run, is it going to vaporize? So as we can see, it's losing mass here. Like, we can see it. Every time I hit it reset mass, it's losing mass. So if we pull it up to Earths or moons, is it losing any moons of mass? Let's have a look here. Okay, it's losing very, very little amounts. So, maybe we'll have to bring it a little closer to the star, because if we look there, that is going to take literally forever to completely vaporize. So if we go to a new simulation here, it looks like all the stars and stuff are stopped now. Planet 9 out there is still completely fine. It's not lost any... Oh, no, it has lost mass, actually. No, I tell a lie, it's lost mass. But still barely any mass at all. Like, if we look here, no mass has hardly been lost. So if we just go into a whole new simulation now. Right, so... Oh, we'll leave the background the way it is. So let's get R1 again, since it's the brightest one. So then let's put the gas giant a little closer. So largest exoplanet, I do want to get to work. So we'll put it about 1 AU. So let's put it at the distance of Earth. So let's pause game as well. So let's put it at 1 AU. Then we'll put yeah, this one here, well, 1 AU as well. And then we'll throw Jupiter in the mix. Why not? Jupiter, you can join the party. So let's put you at 1 AU like so. So let's place it in there. So they should all have the same amount of orbit, or the same year orbit. So they should never collide, which is good. So just place that in there. Come on, 1 AU, please. There we go. So hit play and then pause. Any of these heating up? Look at this, 10,000 degrees now. So this is going to get affected a lot more, I'm hoping. So, but I still want to know if this one is or not. Because it looks like it just goes up to the temperature of a brown dwarf and it stops. So we may have to lower the radius a bit. So if we lock the mass, we may have to lower the radius just so it doesn't go into brown dwarf state. Is it going to do it now? Hopefully. So it just gets up at 2455 degrees, and it reflects all the light. Oh, it could be because it reflects all the light. Oh no, it doesn't. No, it doesn't do anything. Yeah, this isn't a brown dwarf state, this planet, and maybe I need to readjust it a bit so it hopefully doesn't do that. But the density's all changing as well. But is it gonna do anything? Like, it just gets stuck in a brown dwarf mode, as you can see there. So if we just pause, if we just look over here, look at this massive trail. That is Jupiter. Look how much mass Jupiter's losing, and then this exoplanet over here as well. Look at this. So yeah, the largest exoplanet sadly won't work for today. But if we look here, this exoplanet here, one of the second largest, I think this is. And then Jupiter as well. They are losing a lot of mass, so it's proven that this does work, which is good. But sadly, the largest exoplanet just won't work, because I think because the object is so large in the game, it registers it as like a brown dwarf, so it doesn't have the properties of a planet. It acts like a star almost, like all the brown dwarf. So it sort of acts like where is it? 2 mass here. Where is it? 2 mass, 2 mass. Wait, where is 2 mass? Oh, there it is. So it sort of acts like this body here. This does, if we place it here, it's not going to get affected by the starlight, as we can see. See, it's at 2,000 degrees, and it's not even changing. This is the same problem as the largest exoplanet. It's just because it's in a brown dwarf state, it doesn't get affected by the star lightness or the star. So yeah, it kind of sucks. Maybe, well, I guess we can try and make it. Maybe just make it smaller in radius, or lower the mass. Maybe that will fix it. So just, while those two are vaporizing slowly but surely, we'll place another HD in. Let's see if it works. So let's place a U there, and as you can see, it's not losing mass at all. So it's just warming up to its brown dwarf temperature. So I think the only thing we can do is turn that off, lock the radius, and maybe lower the mass. Does that help? Maybe what if we got it to just 20 Jupiters? Is that? See, it still gets stuck in this brown dwarf state. I reckon it's because the radius is so large that it just registers it as a brown dwarf. Because I lowered the mass and it still wants to stay as a brown dwarf. So I reckon the radius is so large on this that it doesn't want to register as a planet in the game. It's just stuck as a brown dwarf object. So I reckon if we lower this to 200,000, it would probably work. Not 300,000. If we lower it to 200,000, hopefully it would fix it. Is it going to do anything? Come on, game. No, it still gets stuck around this temperature. So this planet, I don't know what's up. So we'll just have to go with I'll see how these guys are going. So if we look here, if we just look at the mass loss now. Look, it's lost over 4 moons of mass. So it's losing mass. So if we just speed it up a lot faster now, these should eventually vaporize. And then Jupiter as well. We'll look over here. So Jupiter is losing mass. Look at this. It's going down. So if we just go as fast as possible. Look at Jupiter's mass. It is just going down. It just can't handle it. And then the other exoplanet as well. So this is going down a little slower since it is larger. So it's got, yeah, look at it, 10,000 degrees. Yeah, this is slowly going down, slowly but surely. But Jupiter just can't handle it. poor old Jupiter. He's just completely gone. So if we just look here, it's got less mass than Saturn now, and it's just going into nothing now. It's got less mass than Uranus and Neptune now. Look, if we just look here, and it's just going down, down, and down. It looks like it's, yeah, look, it's gone, completely vaporized by this star. So even Jupiter can't handle it. And then this one here, if we look here, it's losing mass a little slower because it is a larger object, but it is slowly going down. If we look at the mass loss, total, it's lost 13 moons of mass. So this has been affected, which is good. So now we just have to run it as fast as possible. If any, this is going to take a while. So if we just so we go to simulation settings here. If we just turn that off and do this, hopefully it will speed up a little faster. I'm hoping. See, look, if we look at the radius, now it's going down. Whoa, what the heck happened there? Well, the radius was going down, so eventually it would completely vaporize, is what I'll conclude from that. But damn, this star just, what even happened there? Pretty crazy stuff, that. I don't even know what the heck happened there. So just if we quickly check, let's go to the old size comparison simulation, and let's just quickly check. Is the exoplanet size? Whoa, this is just, look at the prototype. This is what it is originally like, but the way I filmed it when I made the size comparison was I did this, and then I filmed it like that. So if we go all the way down here to the planets, all right. So if we look here, so there's HD. Oh, that's not too much. So there's HD. So we just need to lower the temperature just to make it look how it should. So we just 0 degrees. That's what it should look like. So there's 2 mass, which also doesn't get affected. But then we've got this one. This is the one I used in the last simulation. So this is the largest possible planet I have that will work with these stars, or will work that gets vaporized. So yeah, that's the largest object I can possibly destroy just by using starlight or star brightness. So, or star luminosity, I should say. So we're going to put a new R1 there. Then we're going to lock its mass. So position lock, sorry. Then we're gonna get our exoplanet again. So HD, or no, not HD, HAT P32b, and we're gonna place it in a still orbit as well. We're gonna pause. We're gonna place it right there. So we're gonna see if the star can completely vaporize it. So we'll also position lock U. Now we hit play. and watch magic happen, I'm hoping. So let's speed up time. And now magic should just happen. So there should be a smoke trail coming out of this. So let's have a look here. Is it losing mass? Oh, it's going down already. Look at that. It's going a lot quicker. So there we go. It's already lost 30 Earths in mass. This thing is, yeah, this isn't going to work. This thing is going to die. I know I'm repeating myself a lot, but that's truly what's happening here. This is not going to last. Is that a trail there? What's that? Is that a lot of mass loss, or is that just a weird line? I don't know what that line is. Oh well. So let's keep an eye out here. So let's just speed up. So we've also got a timer here. Look, we can see how much time it will take for this thing to completely vaporize. So if you look into astronomy a lot, you may have heard of hot Jupiters before, which is stars or planets that are so close to their stars that they're getting vaporized and eaten alive. And now you may be wondering, how do we discover all these and stuff like that? Well, the fact is the planets don't get incinerated immediately. It takes years and years for the planet to vaporize. And that's pretty much what's happening here. Remember, this is around the most powerful star, or the most bright, or luminous star, sorry. So this would obviously take out the planet quicker. But against a normal sort of red giant star, or something a lot smaller and less luminous, it would take probably hundreds or thousands of years for the planet to completely vaporize. Especially when it's such a large object like this. It's got enough mass it can lose and survive, but Earth wouldn't work because it just doesn't have enough mass to survive. But something this big and this large in mass, it can actually survive because it has the mass to lose. But poor old Earth or a rocky planet just wouldn't stand a chance. But look here, it's lost over 4 Jupiters of mass now, and it's still going. So we just speed up. It's getting smaller and smaller. Look at this. So it's only got a massive 1 Jupiter. We have to slow this down. So if we just look here, now we just have to wait and watch the magic happen. So oh wait, what happened there? It just stopped. Is it still going? Oh no, it's still going down. It's just going slowly but surely here. Look, if you look in the bottom left, the time speeds up, then it just suddenly pauses and it speeds up again. You may have noticed that previously. So let's watch it. Speed up a little. Well, the star's glitching around. Look at that. Why is it doing that? You guys see that? What is going on? It looks like it just spins really fast. What is this? This is pretty weird. Alright, let's keep going. Come on. It's still decreasing. So this thing is now about the size of Neptune now. Neptune and Uranus, it looks like. Yeah, there's Uranus and Neptune. Yeah, so this thing is about the size of Uranus and Neptune now. So yeah, this thing's getting tiny. And it was one of the it was larger than Jupiter originally. You saw the size comparison back there. Like, this thing is very big. So okay, we're going as fast as the simulation will let us now. So we'll just do Control D to get rid of any particles. So is it going to keep going, or is it just going to stop? Let's just turn off the rotation of the star since it's quite buggy. Oh, I wasn't meant to do that. Dang it, I thought that was... Whoops. God damn it. Alright, that's annoying. That's annoying. I was meant to stop the rotation, not turn the lock off. So let's just quickly go in there again. So place you... Yeah, I never use position lock, so it's quite annoying. So just place you, position lock. Then we'll get the planet again. But it will go nice and fast for us. So we'll get our planet. Let's put it really close. Let's put it even closer just so we can get to vaporize. So we'll see that again. So put it there. Then we're going to position lock you. Now we can watch the magic happen. But first I want to stop you from rotating. So turn off the rotational period so it just doesn't turn. And the same with you. So let's just turn it off so they won't spin now. So we hit play. Now we should see some magic happen. So here we go. Now we can really speed it up. Because the only thing that's happening is the star. Like the light from the star. There's nothing else in this simulation is moving up. So now we just have to watch. Oh, it's already just the size it was previously. Maybe it just gets stuck around this size. Is it going to get any smaller? Look, the time is passing really fast now, but it's not getting any smaller or less in mass. Maybe that's a bug, because it should just completely vaporize. Look, the mass isn't being lost anymore. What if we make it slightly smaller? Is it gonna... Come on game. You gonna work? Do that? Does that fix it? Oh, apparently it doesn't want to get any smaller. What if we put it closer to the star? Maybe that helps. Okay, well, where'd the star go? I did not collide it with the star. And it looks like it was so hot it lost all of its atmosphere, so that's all that's left. Well, we'll try it again just to make it, or just to check if it's a fair test. So, just to see if it's the same outcome every time. So we'll place a new star, get our planet back. So let's place you there. So let's just put it there. And then I'll throw in a few other exoplanets as well, just to see if we get the same results. So let's just throw a bunch of them in. Largest exoplanet, that won't work. Let's just place a bunch of exoplanets in here, just to see if it'll work. So yeah, now we'll try that. Then we'll let's put WASP 12b and WASP 17b in as well. Alright, so now we'll position lock all of these guys. And we'll see which ones vaporize, because some of these should vaporize, because yeah, some are a little bigger than others. So let's undo that. I'm gonna lock you. We'll lock you as well. Then WASP 12b. Let's lock you. This was a well-known planet when it was, because these two used to be the largest. WASP 12b and then WASP 17b. I'm pretty sure they had the record for the largest exoplanet at some point. Then we got that, so they're all locked now. Okay, looking good. So now if we just go in chart mode here, these are different sizes. So if we look here, there is a reasonable size to this. So this one here is just a bit bigger than Jupiter, I think. These are all quite large exoplanets. We just go in radius mode here. So yeah, these all are quite large. So right, there's that. Yeah, this planet here is just a little bigger than Uranus and Neptune. But anyways, now we hit play. And as we can see, there is a lot of trails. So those look at this. That's cool. Look at that. Like a spider web almost. This could make a cool thumbnail actually at some point. Maybe I'll use it in a live stream thumbnail at some point. I don't know. Yeah, I should do another live stream soon. It's been a while. But that's pretty cool smoke trail. Look at that. That is really cool. Alright, so this one's probably going to go first if it even disappears because it's the smallest. So let's just speed up. Let's just see what happens. And then we don't go an hour, so we'll go a few months, days, years. That's the fastest we can go. And we'll also make sure to not turn it. We're going to stop it from rotating. So yeah, let's just turn all that off. So rotational period, go away. Rotational period, go away as well. There we go. So I think it rotating does make the simulation slightly slower. So we might as well just turn it all off just in case. So let's go ahead and do that. And this one as well, that, and then that. And then this guy, yeah, that's already done. And we'll delete all particles, and it should hopefully speed it up a bit. So is this the fastest we can run? Or is that really? We can't run any faster than that. Okay, good to know. But yeah, this thing is vaporizing, as you can see. So the mass is going down, down, and down. So yeah, where's our largest one? There's the largest one. So oh, no, it's not. No, that's the largest one. So this one's taken a lot longer than the other ones to go down, but it is losing mass. As you can see, it's losing Earth's in mass every few seconds here, so pretty crazy stuff. I know they're not all the same distance away from the star, but it's not a big deal, honestly. So yeah, there's that. This one's losing a lot more mass as well. So now we just have to wait, I guess. So let's see what happens. If we go in view mode here, if we just go in simulation settings, if we just turn that off, lower this setting a bit. We're not too insane, but we'll lower this. Oh, and then there you go. Look, some have vaporized. They've just completely disappeared as the simulation sped up. So that's good. And this thing is stuck at 1.2 masses of Jupiter again. What about you? 64. Is that getting any smaller? And this one's still going. WASP 17b. That one's is it? Well, it's losing mass. So we're going at the fastest it will run. And it looks like they just get stuck at a certain amount of mass. So it looks like the largest planets. And I'm assuming the same would happen with HD 100-546b, so the largest one. I'm presuming the same would happen with this. Even if we could get it to lose material, it wouldn't completely vaporize as shown here. But I reckon in reality these would vaporize, but for some reason the game just won't allow it. Like this one is still, looks like it's losing material, but it's not getting any smaller in radius, so I don't know what's going on. Yeah, look, the mass loss has stopped, but it should still be going. Look, same on there and then same on you. So to conclude, we can't really say what would happen. I'm assuming in real reality that these would get vaporized completely. It would make sense, but we can't know for sure, I guess. Like the game seems to think that these would survive, but I really don't. These would survive. There's no way planets would survive around this star at this distance, no matter how large they are. So to conclude, I'm going to say that these planets should all be vaporized, but the game won't allow it to be destroyed for some reason. Because look, we'll speed up time literally here. These are not losing mass at all, and at the start when we started it, they were losing mass straight away. So something's obviously fishy here. So yeah, I'm calling this out on the game pretty much. That this is the game. This is an error in the game, not a problem with the planets or anything like that. I think it's just the game won't completely destroy them for some reason. I'm guessing, but hopefully it'll get patched soon. I don't know, but yeah, it looks like from what we're seeing here, the game just won't allow it. So yeah, that's my conclusion to today's video. But anyways, hopefully you guys enjoyed it nonetheless, and yeah, make sure you do leave a like, subscribe for more, helps on the journey to 2,000 before the end of the year, because that'd be cool. And yeah, if you've got any comments or any ideas for another video, feel free to leave them down below, and hopefully the idea will actually work properly, unlike this, because as you can see here, if we resell it, Oh, now it wants to lose mass again. Wait, hang on. Is it going to lose mass? Maybe we had to reset it to fix it. So it says it's losing mass again. So we'll do it with these guys as well. Maybe that helps. May not be the end of the video yet. So if we just speed up. Wow, it really doesn't want to work anymore. No, it's still not losing mass. Look, it's just stuck. The radius isn't getting any smaller, but it should be. Wait, if we just delete both of these. Like that. So this is the only one left. Wait, where'd it go? Control Z. That's meant to undo things. No, apparently not. Actually, before we end this one, we'll do one more. Just in case. Maybe we can get it working. So, just do that. Place a new one in. We'll put the planet really, really close to the star here. So, pause, put it there. Hopefully, Rouge Limit doesn't tear it apart. So, we're going to put it there. We're going to lock your position. We're going to stop you from spinning. So, let's do that. Then the same with you. We're going to stop you from spinning. Like so. Then we're going to hit play. Okay, so Rouge Limit isn't tearing it apart. Then we're going to keep pressing this button. What the heck? Wait, did I position lock it? Oh, dang it. I'm sure I did I? Maybe not. Okay, so let's place a new one. Then we're going to position lock you. Make sure to position lock. Okay, so position lock you. Right, and you're already position locked. Okay, so then what we're going to do is we're going to put that to 0. And the same with you. We're going to put... Whoa, look at that rotational period. That's pretty insane. So we're going to do that. Right, now they're not going to move. So we're going to hit play. Now we should see what will happen. So we speed this up. Like so. As fast as it will go. So there we are. We're going to keep pressing this button here. Because maybe that helps. Maybe. I don't know. So will it get stuck at 1.2 masses of Jupiter or will it survive? So let's just keep going. As fast as it will run. Alright. So... And just keep pressing this button. Pressing Control D to get rid of any particles. And now we just have to watch it happen. Actually, let's just put it to 1.2 already. And will it get stuck? Or will it still go down? Oh, hang on. It got stuck at 1.18. So, remove. So it still says it's losing mass here. But it's not getting any smaller in size. We got made a bit of progress there. What if we put it to just 1 Jupiter? Is it going to get any smaller? But no, it doesn't. That's really weird because Jupiter has one massive Jupiter, obviously, and that got vaporized. So I don't know what's going on. One massive Earth? And now it will go away. So, interesting. But yeah, that will conclude today's video, guys. So, like I said, hopefully you all enjoyed, blah, blah, blah. You know what I said. So, yeah, make sure you have a good day, and I'll see you in the next video. And hopefully you never have to do what I did today with this, because it clearly don't work properly, because that planet should have vaporized. But anyways, yeah, I'll see you in the next video. Goodbye. 0.2 AU, so pretty much around this distance here. So yeah, 5.18, that's close enough. So now what I'm going to do is we're going to delete the old sun. So there we go. So let's go back to the planet now, and we're going to surround it with these stars. So first of all, we'll start off with R1, since that's the one we will start off. So wait, R1, where you are. Yeah, R136A1. So we're going to put this 5 AU away. So 5.2 pretty much. So 5.2, let's put you... Okay, let's just put it in a still mode as well. So 5.2, got to look very carefully here. Okay, 5.21, that works. So there's one. We'll use A to carinate A as well, since you're also one of the brightest. So 5.24444. There's a lot of preparation for this one. So yeah, 5.2. Okay, put that there. Oh, this planet R1. Then we'll do the other R1, and then this R1 over here. So number 3. Then the pistol star. And then Melnick 34 will lock you as well. So now they're all locked. So then HD in the middle will lock that as well, so it cannot move. And just look at this. No matter where you look, it is daytime. The only dark point is under here, since there's no star above or below it, as you can see. So if we just land right in the north here, wherever we look, there are stars. And it's just going to stay like this. So now we just need to see, will this planet get vaporized or not? So, ready for the moment of truth. Let's slow down time, because this thing, either way, this thing is going to heat up in temperature very fast. So, let's go down here, hit play. And as we can see, it's already, if you look carefully, its clouds are already starting to glow orange. So, pretty crazy. We literally just hit play and it's going to get roasted. So then we'll get Melnick 34, so it's also one of them. So, 5 AU, please. There we go. 5.2, okay. So there's that. Then we've got... R1 or R136A2 now, so Let's get U in. So R13682, blah, blah, blah. Okay, so 5.2. Right, there we are. Then we'll get the next one. I'm not even going to say their names at this point. It's just annoying. I always muck up. So there's that. And then the last one is... Or is that all of them already? And then we'll use the pistol star. Why not? Over here. So 5.2 like so. So let's put you there. So 5.2. There we go. So now what we need to do is we need to position lock all of these because we don't want them colliding. So position lock the A to Carone. Then we'll see what happens. So let's let's actually go into a whole new simulation here. Actually, you know what I can just do is I can just do this because I want to keep the cool Christmas background on. Oh, and the sun survived apparently. Anyways, guys, while I'm just quickly setting up, just a many thanks to everyone who subscribed. We are 2 subscribers away right now from 1,700, so that's just amazing. Just cannot thank you. But let's see if we can still try and get that goal of 2,000 before the 1st of January 2018, because that would be awesome. But yeah, I think that's a nice little goal to set. So anyways, largest planet. Oh, I forgot I still have the galaxy-sized gas giant. Forgot we still had that. Alright, so what we got next? Largest exoplanet, you are... Damn it, where is it? I always lose where this one is. There it is. Okay, it's moved slightly since I last used it. Alright, so we'll put it at a distance of... we'll have to lock the positions of objects here as well. So let's put it at 5... Hello everyone, and welcome back to another Universe Sandbox 2 video. And today we're doing another idea commented by you guys. So what we're doing today is we're going to be surrounding the largest exoplanet with the brightest stars. We're going to see if the planet completely vaporizes, because if you remember, quite a while ago I added the brightest star instead of the sun, and it roasted every single object in the solar system apart from Sedna and Planet 9. I think Sedna even died out. I think it was just Planet 9 that was the only survivor. So even Jupiter, the largest planet in the solar system, was vaporized by the brightest star. So we're going to be surrounding the largest exoplanet with... with the brightest stars, and we're going to see if it survives or not. So we'll try it at different distances, but we'll put it around so we'll just see where Jupiter is here, so to get a test of to see how powerful they are. So we'll put them, all the stars, 5.2 AU away from the planet, and we're